So we're going to use the sorted edges algorithm, which optimizes a Hamiltonian circuit. Hamiltonian circuit means we hit each vertex once each, and we get back to where we started. So I'm going to redraw this over to the side to just get the edges I want. Clean up the clutter a little bit. So what do we have? First, we choose the cheapest edge possible, which on my version here seems to be a 3 from A to D. Next cheapest one is a 4 from B to E. Next cheapest would be the 5 from E to A. And reminder of the rules of sorted edges, we want to grab the cheapest edge possible as long as we don't make a premature circuit. So for example, I could not choose B to D, that would make a premature circuit. Or if you make a vertex degree 3. So I wouldn't be able to choose A to B because that would make A degree 3. What do we have next up here? 7. A to C, and that would make A degree 3, so I can't take that. Undo that edge, cross out the 7, not allowed. 8, take us from D to E, and D to E makes a premature circuit, and it makes E degree 3, so 8 is out. Next is 9, and 9 was what I said earlier would make a premature circuit, so that's bad too. So I can't pick that one. 10, can I pick 10? 10 goes from C to E, which makes degree 3, so I can't pick that one either. So I had a lucky start. Now I'm hitting some dead ends, but this will always follow through. Let's see, next cheapest would be from B to A, which would make A degree 3. So that one right there is not acceptable either. Next cheapest would be B to C, and B to C is a 13, and that is allowable. It doesn't give me degree 3 or premature circuit, and I can see the closing here should be the 14, which is the only one left to choose from anyway. And sometimes on these problems, they ask you to give the sum of the circuit that you made, and sometimes they ask for a list starting with, say, vertex A. So if I started at vertex A, I could state it as A, E, B, C, D, and then back to A. I could have gone the other way also, so an acceptable answer would be that this in reverse. So I could state, oops, that's not an E. I could state it as A, D, C, B, E, A. That would be okay too, since this graph goes in both directions. There's not directed line segments here. Or I could state, depending on what the homework asked for, the total amount here. So my total, the cheapest possible Hamiltonian circuit, according to sorted edges, would be this sum here. So 7 and 7 is 14, and 5 is 19. So 39 would be the optimal cost here, the cheapest cost for a circuit.